Hey guys, so this is going to be one of the first videos of the brake playlist. And in this one, I'm going to be talking about basic fundamental hydraulic laws in a hydraulic system. And so when you learn this, one of the first things you got to learn is Pascal's law, which basically states two things. First of all, liquids cannot be compressed. And secondly, most importantly, is pressure is equal throughout a system and goes in all different directions. So everywhere in the system, depending on how much pressure you apply to it, the hydraulic pressure on the inside of everywhere in here is going to be the same pressure. So let's pretend there's 100 psi. Everywhere you look in this system, I even made like little meters on them, they're all reading the same pressure. In this case, they're all reading 100 psi. Because, again, as Pascal law states, pressure is equal everywhere in the system. And, again, it goes in all directions. So it's traveling this way, this way, back at the other way. Even when you press it, it's fighting the pressure back against you and going in the direction that you're putting it in. It goes in all different directions. That's basically what Pascal's law states. Is the liquid pressure inside is all the same everywhere. Now, the input pistons and the output pistons, the amount of pressure, the weight, mechanical energy that they're putting on the outside is going to be different. That's basically what the brake system does. It translates mechanical energy, you pressing on the foot, into hydraulic energy back into mechanical energy. And so how the distance these pistons travel and the amount of pressure that they're creating is going to be dependent on their size compared to each other. So in this example, I have three different ones. I have my input piston, the one that you're basically your master cylinder that's applying that pressure throughout your brakes. And these pistons are three different sizes. We're going to say that this one here is going to be the same exact size as this one. This one here is going to be half the size of that one. And this one here is going to be twice the size of that one. And so what these do, because these ratios, so this first ratio is a half one to it's half the size of this one. So what that's going to do is, when you put, let's say we're putting right here, after you get your linkage, the amount of pressure that gets put on this piston is 100 psi. Because this one is half the size, the output pressure, mechanical pressure that's going to be creating force, is going to be half of it. So it's going to be 50. So you're applying 100 pounds of pressure here, and it's getting an output of 50 pounds of pressure on the outside of it. But the distance is going to be twice the length. Because it's half the size, you're going to get half the pressure, but you're going to get twice the distance. So again, we'll say we're doing 100 pounds of pressure and we're moving it an inch. This is going to move 2 inches and the pressure is going to be 50 psi. This one, because it's the same exact size, it's a 1-to-1 ratio, everything's going to be the same. You're going to move this one an inch, and that one's going to move an inch. You're going to create 100 pounds of pressure here. You're going to get 100 pounds of pressure on the outside of it. And then this one is going to be the opposite of that one. This is going to be, the piston is twice the size, so you're applying 100 pounds of pressure, and you're moving it an inch. So this one, you're going to get 200 pounds of pressure on the output piston. But the distance traveled is going to be half the distance. So you move this one an inch, this one is only going to travel half an inch. So that's the advantages and disadvantages, the distance to weight traveled, the pressure that it creates. And in the automotive brake systems, the pistons, they really don't need to move that much. What's kind of more important is the amount of pressure that they create. So in your car systems, your initial piston up here, which is your master cylinder that creates that pressure, a lot of times is going to be smaller than your pistons at your brakes that apply the brakes. And one last thing is basic fundamental hydraulic rules is the leverage. So here this leverage, depending on how this brake pedal is, on how the leverage is, just like a gear ratio. You turn a little gear turns a big gear, you're going to multiply the torque. Same with leverage. Depending on how it's levered, you can multiply that torque. So you may only be putting, say, 50 pounds of pressure from your foot, but because that multiplies it, it translates to 100 pounds of pressure here. And that's basically how the fundamental basic system of hydraulic systems work. Thanks for watching.